Hello, this video is about reacting masses, which is part of the quantitative chemistry unit for GCSE chemistry and combined science. In this video, I intend to talk about how to do the reacting masses questions in a kind of a formulaic way, step by step, always following the same steps, and just work through some worked examples. So these are the sort of questions that you might get for a reacting masses question. What mass of calcium oxide is needed to produce 40 grams of calcium hydroxide in this reaction? And I've given the equation there as well, and I've just popped the periodic table into the corner so we can talk about where the support for this question will come from in terms of your data sheet in your exam. So this is kind of a necessary calculation for those working in industry. If you're working in industry and you want to make something like calcium hydroxide, and you know how much you need to produce business-wise, then you will need to know what sort of masses of calcium oxide and water you're going to need to buy in so that you can produce the right amount of calcium hydroxide. Obviously, the more reactants you start with, the more product you can make, but we need to know it in terms of actual masses in grams, kilograms, tons, and so on. So I just want to talk through the key features of how I would work through one of these questions. And make that really clear before we start, and then if we stick by these rules, these questions should all begin to look pretty much the same. Okay, so here is my key guidance for these sort of questions. First of all, we're going to use this equation, and any information that you know or you want to know should be written underneath the appropriate formula. That ensures that you know which chemical you're talking about when you give a mass in grams or an MR value or a number of moles. You will know straight away which of these three substances you're talking about if you've written it underneath the correct one. Secondly, mass and MR are both kind of masses in a way, so it's important that we know which is which and we can differentiate between them. So mass is in grams, kilograms, tons, etc. It's how much stuff you have got or you are trying to create. MR is the relative mass, and that's the one taken from the periodic table. And my fourth key tip for doing these questions is, if all else fails, aim to calculate moles of something and you will get partway there. So we are always trying to get moles in these questions. So let's go ahead and take a look at this question and how we would use these rules to apply to this particular question. Alright, so this is what I'd be given in an exam. I have the question and I know that I'm always going to be given a data sheet with the periodic table on it. First thing is first, the equation must be balanced. So the first thing to do is to check that this equation is a balanced symbol equation, and there are no big numbers in this, so I would definitely look at it and make sure that it is balanced first. If you see an equation that's got big 2's and big 3's, usually they are balanced for you. I can't imagine them giving you an equation that's partially balanced, unless that's one of the questions that's clearly stated. So this has got no big numbers, it's worth checking that this is balanced. I'm not going to go through balancing equations right now, but just very quickly we can see that we've got one calcium here and one there, so that's fine. We've got two hydrogens here and we've got one there, but it's doubled, so we've got two hydrogens there, so that's fine. And we've got one oxygen here and one there, so that's two in total on this side. And we've got one in here, but again, it's doubled, so we've got two on that side. So that's fine. We've got a calcium on each side, we've got two hydrogens on each side, and we've got two oxygens on each side. That equation is balanced. Now, the next thing I would do here with the space that I'm given is I would spread this equation out so that it reaches across my page. And that's so that I've got plenty of space underneath to write whatever I need to write. So I'll put calcium oxide over here, plus water makes calcium hydroxide. That gives me loads of space to write what I need to write underneath. Okay, so that's my first step. Check it's balanced and spread it out. My second step would be to write down anything that I know or that I'm trying to find. It's all there in the question. Write those pieces of information under the appropriate chemical. So we have got what mass of calcium oxide? That's the question. So what mass of calcium oxide? Okay, and I can see that we're working in grams at the moment, so I can stick grams after here. How many grams of that? That's what we're trying to find out. It also says is needed to produce 40 grams of calcium hydroxide, which is CaOH2. So we will right underneath that one, 40 grams of that. So that's what we're aiming for, and that's what we're trying to find out. And I've written them under the appropriate chemical. Now, if I couldn't go any further than that, I need to remember that my aim is always to find moles. And I can't find moles at the moment because I don't have enough information. I have a mass, which is useful. So I've got a mass of calcium hydroxide. How would I get moles? Have a little think. How would I get moles if I know mass? What else do I need to know? And the answer, because the equation for moles is moles equals mass over MR, I need the MR. Okay, so I can find the MR of any chemicals that I'm interested in here, any substances I'm interested in. Now, I've not been given any information for water, so I'm not going to use that. But I am trying to find this one, and I do know something about this one. So I'm going to calculate MR for both of these substances. So using the periodic table, we have got calcium is over here. Oh, that's not the right pen. Calcium is over here. We've got oxygen, which is up here. And we've got hydrogen that's going to be involved as well, which is here. And we're looking at the relative atomic mass, and the key tells us that's the top number. So we're looking at this number here, and this number here to work out MR. So MR for calcium oxide is 1 calcium, which is 40, and 1 oxygen, which is 16. So the MR for calcium oxide is 56. Doing the same process over on the right-hand side, I've got a calcium, which is 40, and then I've got an oxygen and a hydrogen, which is a 16 and a 1, but I need to double that. So that's 17. I'm going to double that up and add that together. So my relative formula mass, my MR of calcium hydroxide, is 74. Okay. Now that I know the mass and the MR of one of my chemicals, I can now work out moles for that particular substance there. I can work out how many moles we've got. So I'm going to use this equation, moles equals mass divided by MR, to calculate the number of moles for this one. I can't calculate number of moles for this one because I don't know the mass yet, so I'll leave that one alone, and we'll calculate it for this one. I'll just get rid of the periodic table so that I've got plenty of space. Okay, so over here I'm still working underneath this one. I know that moles equals mass over MR, so that is equal to my mass, which is 40 grams, over my MR, which I've already said is 74. So by keeping everything within this column, whenever I come to try and find the mass, I can just look up and find the mass. Whenever I come to find the MR, I can just look up and find it. So I keep all my information together, which is really useful. That means that I have this number of moles, 40 divided by 74, which is equal to 0.54 moles. And that means 0.54 moles of calcium hydroxide. So one of my key tips was aim to calculate moles, and we've done that for one of them. Moles are great because as soon as you have moles of one thing, you can move along and start calculating what you've got elsewhere. So we can now find out how many moles of water or how many moles of calcium oxide we've got in this reaction. Calcium oxide is what we're looking for, so we're going to try and move across. Okay, so we want to go from how many moles of this to how many moles of that, and then we can work backwards to find mass. So let me just move that equation out of the way. There we go. Got plenty of space. Now, to be able to do that, you need to use the mole ratio, and the mole ratio is simply the balancing of the equation. So how many moles of this react with how many moles of this to make how many moles of that? Now, because we don't have any big numbers, it's just a 1-to-1 mole ratio. So I'm skipping out this one. I don't care about water, but it is, the mole ratio is 1 to 1, which means if you've got 0.54 moles over here, you're going to have exactly the same over here because it's 1 to 1. Okay? So I've gone from, just to recap, writing down what I know and what I don't know under the appropriate chemicals, and then calculating MR for anything that I'm interested in. Once I've got those two pieces of information, I'm able to do moles. Okay, I'm able to calculate moles, which is where we're aiming for. So I calculate moles using this equation, which you must remember, moles equals mass over MR. Plug in my numbers, and I get a number of moles. Once I'm at moles for the chemical I know something about, I can start looking at moles for chemicals I don't know something about, so I can move over here. And I can't just copy the number of moles from here to here. I have to check out the mole ratio first. I have to find out how many lots of this create how many lots of this. Unfortunately, it's 1 to 1. So however many moles we've got here, that's how many moles we're going to have here. Now in this column, I have enough information to calculate something else. I know moles and I know MR. That means that I'm now able to use this equation here to calculate mass, but I'm going to rearrange it. So to rearrange that equation, we have mass equals moles times MR. That's equal to, if I look back up my column, so we're talking about calcium oxide now, that is equal to 0.54 times the MR, which is 56. Okay, this is where it becomes really helpful to work in columns, because we've got an MR over here, we've got an MR over there, we've got moles here, we've got moles there. We need to know which one we're talking about at any one time. So if I plug that into a calculator, 0.54 times 56, I get my mass, which is equal to 30.24 grams, and we put the units at the end. And that is exactly what we were looking for. The question was, what mass of calcium oxide is needed? And there is our final answer. Okay, so just to go through again, the stages that I used to answer that question. So first we did the full balanced equation, and we spread it out across the page. Then we wrote what we know and what we don't know from the question, which are masses. So what mass do we know? What mass are we trying to find? And I write them underneath the appropriate substance. Then we use the periodic table to calculate MR for the substances that we are interested in. Then calculate moles for whatever I can. Then to move over, we look at the mole ratio, and that will tell us what the moles of the other compound is. Then we use the equation moles equals mass over MR, but rearrange it to calculate mass, and then we check that the units are correct. So it's the same steps no matter what you're trying to answer. So we'll do another question exactly the same, and I'll show you how each of these steps is exactly the same as the last example. Okay, so here's another example. What mass of sodium chloride is produced when 25 grams of sodium is reacted with excess chlorine? So here we've got that it mentions that chlorine is in excess, which means we don't need to know anything about it. It really doesn't matter. The ones that we do care about is how much sodium we've got, because that will limit how much sodium chloride we can make. And we need to know what mass of sodium chloride we're actually going to make based on using 25 grams of sodium. So the chlorine we don't care about, because excess means we've got more than enough. It's not going to affect our reaction at all. So the first step is to write out the full balanced equation and to spread it out. So we have sodium plus chlorine makes sodium chloride. I'm going to balance it just to make sure, because we've got 2 chlorines going in, so we'll double up our sodium chloride. And because we've now got 2 sodiums coming out, we'll have 2 sodiums going in. Balancing equations is for another lesson, so we'll leave that there as it is. And that means that we have now done that part there. Next step is masses that we know and we don't know in grams from the question. So having a look at the question, we know that we've got 25 grams of sodium. We know that this one is in excess, which means we don't care about it. And we know that this one is the one that we're trying to find. How many grams of that can we make? And I've written them underneath the appropriate substance again. Okay, so that one we have now done. The next step is to use the periodic table to do the relative formula mass. So I'm going to introduce a periodic table. So now we've got our periodic table, we need to calculate the MR of any chemicals that we are interested in. We're not interested in that one because it's in excess, but the other 2 we are. So we have got sodium, which is over here, which has a relative atomic mass of 23. And we've got sodium chloride. So again, we use sodium again, but also the chlorine, which is over here. Again, if you're not sure which one's which, you look at the key and find that the relative atomic mass is the top one. So that's this one and this one. We're going to use those numbers to calculate AR and MR. Okay. With sodium, it's actually AR. It's relative atomic mass because it's just sodium. But NaCl is a formula, so we call that one MR. All right. So sodium from the periodic table is 23. Don't worry if you write MR instead of AR, it really doesn't matter. But the correct one for this would be AR because it's just a single atom on its own. And the MR of this one is going to be 23 plus 35.5, and that gives us 58.5. Okay, so periodic table has done its job, so we'll get rid of that. And now we can carry on looking at the different stages that we've got to do. So we've done that. The next one is to calculate moles. Now, something here will have enough information for us to calculate moles. It may be the first substance, it may be the middle substance, it may be the last substance. So look for the one that's got enough information for you to calculate moles. This one here, I have got the mass and I've got the AR or the MR. So I can calculate moles for that one. My equation, which I'll write just on the left-hand side here, is moles equals mass over AR or MR. It's the same thing, relative mass from the periodic table. So we can do that for this one. So moles equals mass over AR. Take your numbers from above, so go back up your column. We're looking for mass. We've got it here, which is 25. So we've got 25 grams over, and again, look back up your column to get the AR or the MR over 23. And if you plug that into a calculator, it will give you the number of moles of sodium that you are using in that reaction. So my calculator gives me 1.086956 and on and on and on. So it's actually 1.09 if we want to round that to two decimal places. Okay, and just to remind us what that number means, it is moles of sodium because we're writing it underneath the Na. Okay, so we've done moles, so we can tick that one off. We've calculated it for the one that we can. We can't calculate it for sodium chloride because we don't have enough information. So we go on to our next step, which is calculating the mole ratio. And the mole ratio is where you look at the balancing of the equation. So I'm going to write that down now. So the mole ratio for sodium to chloride, oh, that's not the right one. That's the one. Sodium to, two lots of that, to 1 mole of chlorine, to 2 moles of sodium chloride. Now, obviously, we still don't care very much about this one. We're not bothered about that. But we do care about the 2 to 2 mole ratio because we're trying to move from talking about sodium to now talking about sodium chloride. 2 to 2 is equal the 1 to 1. Okay, so it's a 1 to 1 mole ratio, which means however many moles of this one we have the same number of moles of this one. So we can move that over. Okay, so we have calculated the mole ratio. We have now found the moles of the other compound using the mole ratio. It's 1 to 1, so the number of moles is the same as it was for sodium. The next step is to calculate the mass, and we already know an equation, which is moles equals mass over MR. So let's rearrange that. Mass equals moles times MR. So that's what we're going to use to talk about sodium chloride. And because I'm talking about sodium chloride, I'm going to write it underneath its formula. So the mass for this one is equal to moles times MR. To find the moles, look back up your column and you'll see it here. It's 1.09. And to find your MR, look back up your column and you'll find it here. So writing in columns just keeps you on track. So that's equal to 1.09 multiplied by 58.5, and that will tell us the mass. Okay, so the mass is equal to, if we plug that into a calculator, the mass is equal to 63.6. So we'll write that in there, 63.6, and the units, we're working in grams. Grams. Okay, the question asked us for what mass of sodium chloride is produced. So sodium chloride, we now have a mass. There is your final answer. If you start with 25 grams of sodium and an excess of chlorine gas, the most sodium chloride you can make, if nothing goes wrong, is 63.6 grams. Right, okay, well now I'm hoping that you've seen 2 examples that do exactly the same, follow the exact same process, the exact same set of steps. So this is going to be my final worked example just to show you that again, it's exactly the same. So the question here is what mass of oxygen is required to fully react with 150 grams of hydrogen in this reaction, and the equation's given for us. The first step in my list of instructions is the full balanced equation, and again I'm going to spread it out across the working space. So we've got 2 lots of hydrogen reacts with 1 mole of oxygen to make 2 moles of water. Okay, and I have done that one. The next step is to write in the masses that we know and we don't know. So having a look at the question, it asks what mass of oxygen, so that one's going to be a question mark. What mass of oxygen? So find oxygen, and underneath it, we're going to write what mass. It also tells us in the equation, in the question, that we are fully reacting it with 150 grams of hydrogen. So let's find hydrogen, and underneath it, we're going to write down that it's 150 grams. So hydrogen is over here, 150 grams. And the only other information it gives us is the full equation, which we've already used. So we've done that step there. We can be happy that we've completed that. So the next step is to use the periodic table to calculate the relative atomic mass or relative formula mass. So let's grab a periodic table. All right, so the chemicals that we're interested in are hydrogen and oxygen. It's not given us any information about the water, so we don't really care about the water. So the hydrogen, we're going to use the mass here, and the oxygen, we're going to use the mass here. The key tells us that the relative atomic mass or relative formula mass is taken by using these numbers at the top. So we're going to use the 1 and the 16 to calculate the relative atomic mass or relative formula mass. So for the hydrogen, hydrogen comes in twos, it's diatomic, it's H2, which means you've got two of these. 1 and 1 is 2. So the relative formula mass for this one is 2. Okay, just a word of warning, do not use the balancing, don't use the big numbers when you're calculating relative formula mass. That just means 2 lots of it, 2 moles of it. The formula is anything including letters and small numbers, so that's what you're actually calculating the formula mass of. Oxygen, also diatomic, comes in twos, so we're going to take the 16 and we're going to double it, so the MR for the oxygen is 32. And the periodic table has done its job, so we're going to get rid of the periodic table. Let's delete that. And we have now done this step here, which is to calculate MR. Okay, our next step is to calculate moles. We know the equation for moles is mass over MR, so have a look across everything that you've done and find the one that you can calculate moles for. The one that we have the most information for at the moment is hydrogen, so we're going to calculate moles of hydrogen. Moles equals mass over MR. Look back up here for your mass, which is here, and your MR, which is here, and plug them into the equation. So that is 150 divided by 2, which means, let's get rid of that because that's going to drop down into our next box, and I don't want to do that. Okay, so that's equal to 75 moles. So we know the moles of hydrogen, which is great. And remember that moles means that you can now move over and you can start talking about a different chemical. So we're able to move over now and we're able to start looking at what goes on over here. Okay, so how do we do that? How do we move over? Well, you can't do it unless you've looked at the mole ratio. So we've done that one, we're now going to look at the mole ratio. Using the balancing of the equation at the top, so I'm just going to highlight up here, we've got 2 moles of this, reacts with 1 mole of that, to produce 2 moles of that. So the two substances that we're interested in are the hydrogen and the oxygen, and the mole ratio for that is 2. Keep using the wrong pen. It's 2 to 1. Okay, so now we do have to do something with our ratio. This one's a little bit different. Because it's not 1 to 1, that means that although we've got 75 moles here, we don't just automatically have 75 moles here, we have to use this ratio. The number of moles of hydrogen is twice the number of moles of oxygen. So we're going to have to take this 75 moles and half it to find the number of moles of oxygen. So 75 divided by 2, I'll just write it in so that you can see the working out. 75 divided by 2, according to the ratio, is going to be 37.5 moles of O2, and we're writing it underneath the formula O2. So now we know the number of moles of the other compound, which means we can tick some more instructions off our list. We've found the mole ratio and we've used it to calculate the moles of the other compound. So now we're up to the bit where we actually get the answer. We're going to calculate mass of O2 because that's what it asked for in the question. What mass of oxygen? And we can do that now because we can rearrange the equation for moles into mass equals moles times MR. And again, we're going to look up our column to find out what the moles and what the MR are. There's the moles, there's the MR. Let's plug those into the equation. So mass is equal to 37.5 times 32, which is equal to, if you plug it into your calculator, 1,200, and it's mass, and we're working in grams, so 1,200 grams of oxygen is required to react with 150 grams of hydrogen. And if you double check the question, what mass of oxygen is required to react fully with 150 grams of hydrogen, you can just check that you've actually answered the question you were asked, and you have. It's 1,200 grams of oxygen. So these instructions that are down the left-hand side of the screen now, if you follow those, then without fail, you'll be able to do reacting mass questions. The problem is knowing what those instructions are step by step, and it looks like a lot when it's like that, but it's not. We're working with an equation, so write it out. The question tells us some stuff. It's good practice to write down what we know. Once you get to here and you've written down the equation and the masses in grams, you've got to look for some help somewhere. So if you can't remember what comes next, hopefully maybe you'll remember that you're trying to get to moles and you'll realise that you can't get to moles without finding the MR. Or maybe you'll go, I haven't got a clue what to do next, so I'm going to use my periodic table and see what I can find. And then hopefully you'll come up with the idea of calculating relative formula mass. And then again, if you can't remember what comes next, look at the information you've got and go, right, what can I do with this? I've got a question mark, I've got an MR, I've got an MR, and I've got a mass. And hopefully that will trigger your memory that you know an equation that links mass and MR, which means it will take you to calculating moles. Okay? And then if you got this far, you'll get quite a lot of marks on these questions anyway. So it's just a case of finding a way to remember the steps here, one after the other. Okay, and I would suggest that you practice using these steps over and over again and then begin to take them away. Okay, so use them, then take them away for a few, and if you need it, have a little look, and then try and take it away completely. And if you do enough of them, practice makes permanent, so I think you will get there eventually. So I'm hoping this helped, but that's exactly how to do it for every single one of those questions, and they are exactly the same. So well done for listening. Practice some of these questions, see how they go, come back and watch the video again if you need to.